Wildcat, so we're going to using structures to factor polynomials 1.2. Certain polynomials in quadratic form may have common factors in some of the terms, but not in all terms. In this case, it may be helpful to write the terms as a product of two terms. You can then substitute the common term with the variable z and factor as you would any polynomial in quadratic form. This method of factoring is called chunking. All right, go and look over the worked example. All right, now if chunking works for you, you can use that, but in this case, I'm going to, instead of use chunking, reverse box method. Okay, to factor and identify the zeros. Okay, so first term, last term. Now we need to figure out what multiplies to give you 25x squared. Well, the answer to that is 5x and 5x. Okay, now we need to figure out all the numbers that multiply to give us negative 21. And then when we find them, these need to combine to be 20x. Okay, since the middle number is positive, the bigger number is going to be positive. Okay, so let's look at all the combinations that make negative 21. So negative 1 times 21 equals negative 21. Negative 2 doesn't work. Negative 3 times 7 is negative 21. Okay, so those are all the combinations. Now, this number seems really big to get to 20, so I'm going to try these combinations first, okay? So let's put a minus 3 here and a positive 7 here, okay? So if this works, these boxes will combine to be 20x. So 5x times negative 3 is negative 15x. 7 times 5x is 35x. 35 minus 15 is 20x, so this works. So the factors are 5x minus 3 times 5x plus 7, and we're going to set that equal to 0. Okay? All right, so we're going to set 5x minus 3 equal to 0, 5x plus 7 equal to 0. We're going to add 3 to both sides. We get 5x equals 3. Last step, we divide both sides by 5. Well, 5 divided by 5 is 1. So x equals 3/5, which let's go ahead and get that as a decimal. So 3 divided by 5 is 0.6. Which, graphing that, let's just put that approximately right here. Okay? All right, now let's go ahead and solve this. So we subtract 7 from both sides. We get 5x equals negative 7. Divide both sides by 5. 5 divided by 5 is 1. So let's go ahead and get that as a decimal. So negative 7 divided by 5 is negative 1.4. Okay, so let's just graph that about somewhere about here. Okay, and then we'll sketch our graph, which is this. All right, go ahead and finish up number 1. And if you wanted to verify the graph is correct, you could graph this in Desmos. All right, let's take a look at the next page. All right, go ahead and mark out question number 2. All right, a special form of polynomial is a perfect square trinomial. Perfect square trinomial has first and last terms that are perfect squares and a middle term that is equivalent to 2 times the product of the first and last term's square root. Factoring a perfect square trinomial can occur in 2 forms, which are here. And let's go ahead and list a few of the perfect squares, okay? So x squared minus 1 factors to be x plus 1, x minus 1. X squared minus 4 factors to be x plus 2, x minus 2. X squared minus 9 factors to be x plus 3, x minus 3. And then x oh, that should be it 2. X squared minus 16 equals x plus 4, x minus 4. And then you can just dot, dot, dot. We can keep going on infinitely. Okay? All right. Go ahead and write that down. All right, let's take a look at 3. Determine which of the polynomial expressions is a perfect square trinomial and write it as the square of a sum or difference. If not a perfect square trinomial, explain why not. Okay, so we're going to factor this using the inverse box method. So first term, and we're going to change that to a plus 49, last term. Now, we need to think about what makes x to the fourth. Well, that's x squared and x squared. And we're thinking perfect square, so same number, okay? So to get 49, we use plus 7, plus 7. And as this works, we'll get 14x squared right here. Okay, so let's check. X squared times 7 is 7x squared. 7 times x squared is 7x squared. 7x squared and 7x squared is 14x squared. So this factors to be x squared plus 7 times x squared minus 7. All right, go ahead and finish up A. All right, let's take a look at B, and let's go ahead and change the middle number to be negative 80. Okay? So first term, last term, and we ask ourselves what multiplies to give you 16x squared? Well, the answer to that is 4x and 4x. And we need to figure out what combination will combine to be negative 80x. Okay, we want the same number. So to get 100, let's use minus 10 and minus 10. So 4x times negative 10 is negative 40x. Negative 10 times 4 is negative 40x. Negative 40 and negative 40 combine to be negative 80. So this factors to be 4x minus 10 times 4x plus 10. All right, go ahead and finish up B. All right, let's take a look at C. So first term, last term, and these need to combine to be negative 32x. Okay? Well, to get 64x squared, we know we can use 8x and 8x. And we need to figure out what numbers give you a positive 4. The only number that really works is negative 2 and negative 2. Okay? Well, 8x times 2 is negative 16x. Negative 2 times 8 is negative 16x. This combines to be negative 32x, so this factors to be 8x minus 2 times 8x minus 2. All right, so let's take a look at D. So we have 9x to the fourth, positive 1, and these combine to be 6x squared. Okay, well, we ask ourselves, what multiplies to give us 9x to the fourth? Well, that's 3x squared and 3x squared. And then the only possible combination to give us 1 is a plus 1 and plus 1. So 3x squared times 1 is 3x squared. 1 times 3x squared is 3x squared. This combines to be 6x squared, so this factors to be 3x squared plus 1 times 3x squared plus 1. All right, go ahead and finish up number 3. All right, let's take a look at the next page. In polynomials of 4 terms, you may notice that although not all terms share a common factor, pairs of terms might share a common factor. In this situation, you can factor by grouping. Colt factors the polynomial expression x cubed plus 3x squared minus x minus 3. So we factor out an x squared from the first 2 terms, and we factor out a negative 1 from the first 2 terms. Then we group these together, and then this is a difference of square, becomes x plus 1, x minus 1. All right, let's go ahead and explain the steps. X cubed plus 3x squared minus x minus 3 Step 1, factor out an x squared from the first two terms and negative 1 from the last two terms. Step 2, factor out x plus 3. Step 3, factor x squared minus 1 using the difference of two squares. All right, let's take a look at the next step. Use the factors to identify the zeros of f of x equals x cubed plus 3x squared minus x minus 3, and then sketch the graph. So we said x plus 3 equals 0, x plus 1 equals 0, x minus 1 equals 0. So we subtract 3 from both sides, you get x equals negative 3. Subtract 1 from both sides, you get x equals negative 1. Add 1 to both sides, you get x equals 1. So let's add our tick marks. So negative 3 is right here. Negative 1 is right here, and 1 is right here. Okay, so our graph looks like this. All right, go ahead and finish up B. Let's take a look at the next graph. Okay, number 5. Use factor by grouping to factor and identify the zeros of f of x equals x cubed plus 7x squared minus 4x minus 28, then sketch a graph. So we have x cubed plus 7x squared minus 4x minus 28 equals 0. Okay, we can factor out an x squared from the first two terms, which leaves x plus 7. And then we can factor out a negative 4 from the last two terms, which leaves x plus 7, and then that's equal to 0. Let's group these together. So then that's x squared minus 4 times x plus 7 equal to 0. Well, this is a difference of squares, so this becomes x plus 2 times x minus 2, and then times x plus 7. And that's all equal to 0. So we set x plus 2 equal to 0, x minus 2 equal to 0, and then x plus 7 equal to 0. Okay, so we subtract 2 from both sides, you get x equals negative 2. And then we add 2 to both sides, we get x equals 2. And then we subtract 7 from both sides, we get x equals negative 7. So negative 3, negative 4, negative 5, it's negative 7. So we need to extend our line out. Okay? And then our graph looks like this. All right, go ahead and finish up number 5. Mark out number 6. All right, let's take a look at the next page. Okay, some degree 4 polynomials written as trinomials ax to the fourth plus bx squared plus c have the same structure as quadratics. When this is the case, the polynomial may be factored using the same methods you would use to factor a quadratic. This is called factoring using quadratic form. All right, go ahead and look over the worked example. All right, for each polynomial over the set of complex numbers, use the factors to identify the zeros and sketch the polynomial. Okay, so here we can factor out an x cubed from each term, which leaves x minus 4. And then here we can factor out a negative 1x from both terms, which leaves x minus 4, and let's set that equal to 0. We can group these together, so that's x cubed minus 1x times x minus 4 equal to 0. We can factor out an x here, so that becomes x times x squared minus 1 times x minus 4 equal to 0. This is a difference of squares, so that becomes x times x plus 1, x minus 1, x minus 4 equal to 0. So we set x equal to 0, x plus 1 equal to 0, x minus 1 equal to 0, and then x minus 4 equal to 0. So x equals 0. We subtract 1 from both sides. X equals negative 1. Add 1 to both sides. X equals 1. Add 4 to both sides. X equals 4. Okay. And then we sketch our graph like so. All right, go ahead and finish up A. Let's take a look at B. Now here we can actually use two parentheses. Now we know that x to the fourth, because we can multiply x squared times x squared. Now when you figure out what numbers multiply to give you positive 9 combined to be negative 10. So to do that, we'll start with negative 1 times negative 9 is a positive 9, and then negative 1 minus 9 equals a negative 10. So we have our 9 and negative 10. So the factors are x squared minus 1, x squared minus 9. Now, these are difference of squares, so that can be factored to be x plus 1, x minus 1, and difference of squares again, x plus 3, x minus 3 equal to 0. So x plus 1 equal to 0, x minus 1 equal to 0, x plus 3 equal to 0, and then x minus 3 equal to 0. So we subtract 1 from both sides, you get x equals negative 1. Add 1 to both sides, x equals 1. Subtract 3 from both sides, x equals negative 3. Add 3 to both sides, x equals 3. So negative 1, positive 1, negative 3, so 2, 3, and then 1, 2, 3, positive 3. And then sketch of the graph looks like so. All right, go ahead and finish up B. All right, let's take a look at the next page. Go ahead and mark this page out. The student works 1, 2A, and 2B. The student works 1A and 1B. And the student works 2A, 2B, 3A, and 3B. All right, go and finish up your notes, start working on the assignment, and have a wonderful Wildcat day.